We'll proceed in innovative approach in calculus, and we will proceed calculating the integration of sin x through polar coordinate way. So calculation of the integration of sine wave through polar coordinate way. What we have seen anyway means someone can, if someone asks that can you calculate the integration of sine x, then anyone one would respond that it's not possible. I cannot calculate the integration of sine x. Instead, I can calculate differentiation of sine x through the first principle. So this is what I can do, differentiation of sin x through the first principle. But I cannot calculate integration of sin x. So we have taken the charge to calculating the integration of sin x and through the trigonometric way, through the polar coordinate way. What is the integration of sin x? So we have seen that integration of sin x is indeed, it is minus cos x. It is indeed minus cos x. Now, now the idea is that we will proceed. Okay, so idea is that we will proceed in the calculation of integration of sin x. And what is the problem? What is the problem that we have seen while calculating the integration of sin x? What is the problem we have seen? So if I have, how we are calculating the kind of sin x. So what we consider that, consider this is a circle. If this is a circle, then this is x-axis. This is x-axis, and there is a, this is x-axis in the circle. What was the problem in our calculation? In past video, we calculated the integration of sin x. So what we want? We want sine theta d theta. That is the integration of sin x. Integration of sin x is sine theta d theta. That is the integration of sin x. In that way, okay, integration of sin x is sine theta d theta. Okay. Okay, so how to calculate integration of the sin x? That is the question. And integration of sin x is sine theta d theta. Very nice. Means anyone would say, everyone knows it. While calculating the integration of sine theta is nothing but sine theta d theta. Okay, what we did while calculating the integration of sine theta d theta? What we kind of try to achieve. So if someone asks, then what we did when calculating the sine theta d theta? Okay, what we did. Now if I have a circle and this is x-axis, then this is the radius. Initially radius is sitting at the x-axis, now radius is rotating. Now at any particular time, there is a theta angle. There is a theta angle, and this is the point that is touching the circumference, that is the radius. This is the height. Okay, if I take it away, then this is x-axis, this is radius is sitting on the x-axis and radius is rotating. At one point it is angle theta and height is h. This is angle theta and height is h. If that is the case, now I move angle d theta. Okay, this is new h. This is previous h and this is new h. If that is the case, then at previous h, now this is new h. Okay, now this angle is theta plus delta theta. It moved delta theta. This angle is theta plus delta theta. This angle is theta and this angle is delta theta. In that sense, this at theta height is h. Then now the height is h plus delta h. This is h and this is h plus delta h. Now this delta theta movement in angle, it lifted delta h in the height. In that scenario, what is sine theta? If this is, I'm sorry, if this is theta, then what is sine theta? H by hypotenuse. H by R is the sine theta. So sine theta d theta. We have done it. Sine theta d theta. H by R, where R is constant, because if you keep changing angle also, this R will never change. This height is changing. So H by R d theta, or H by R dH by dH into d theta. H by R dH d theta by dH. Okay, 1 by r I can take outside, integration of h dh d theta by dh. This is our proof. You will not get anywhere else. Now, in that sense, now, now let's come back to the let's come back to the circle. Okay, I'm not repeating anything. So we will proceed on it. So let's consider the circle back. And in this circle, so this is the x-axis. Now this x-axis is moving, and now it is making theta degree with the x-axis. This is x-axis, this position is x-axis. It is moving and it is making theta degree with the x-axis. Now this is the point. One point is there where height is h. Now it is moving again delta theta, and this is another point. Now this point and this point, this arc is r d theta. If this arc is 2 pi, if the angle is 2 pi, then this arc is 2 pi r. People know it. If this moves delta theta, then r into delta theta is this section of the perimeter or arc. If that is the case, this is the point where height is h from the x-axis. And this is the point, if I take like this, it forms a triangle. From here, old position, there is a straight line. And new position, if I draw a flat line, then it makes a triangle. This side, it makes a triangle. Triangle height is delta h, because this height is achieved because of movement from theta to, from, it was at angle theta, then it moved delta theta. Because of movement of the delta theta, this point and this point, 2 points formed. One point was already there at angle theta, new point came at theta plus delta theta. This is the arc. If that is the case, then from theta plus delta theta, I can draw a line parallel to x-axis. And from previous point, I can draw perpendicular to the x-axis. Then this is a triangle. Okay. This triangle has one side is delta h, another length is unknown. This is what I would say. And another hypotenuse. This is right angle. This triangle is a right angle here. And another line is point this, earlier point and new point connecting this point. So this is a triangle that if this is old point at angle theta, and this is new point at angle theta plus delta theta. This span is delta theta. This point, parallel to x-axis is this line, and this is delta h. So this is one triangle where this angle is 90 degree. This angle I have to find. This angle I don't care right now. What is this length? This is the arc of the circle. This is the arc of the circle. This is the arc of the circle. Okay. If this is the arc of the circle, what is the arc? R d theta. Since d theta is very small, right now I am taking the approximation. If d theta is very small, this arc length and this length I can consider the same. If that is the case, then this length is r d theta. Then this is delta h. What about this angle? Now this is more or less, if I take any circle and I am talking about 2 points on the circle, if at any point, this is theta point, this is x-axis, this is theta angle, this is the point. At this point, if I take a kind of a tangent at this point, this tangent would make 90 degree with the radius. If this is the radius, and if I talk about tangent, the radius and tangent would make exactly 90 degree. Exactly 90 degree. But this is not the tangent. Anyway, If I am talking about this is at angle theta and delta theta it is moving, there are 2 points. These 2 points, if I connect, it makes a line. But since delta theta is too small, it can be considered a tangent at that point. If that is the case, the new circle, new triangle we are forming like this and this is theta degree. This is center of the circle and this line is at theta degree. This is center of the circle. Then this line is theta plus delta theta. If that is the case, then this is the line from the okay, this is the line from the center. This is the line from the center. This height is h and this height is delta h. This line, this makes 90 degree here, approximately 90 degree here. Now we have other triangle. This line perpendicular that is delta h. I am sorry, h delta h. This is r delta theta. Now this is r radius. This h and this makes a triangle. Delta h r d theta and this makes another triangle. What about this angle we are trying to find? This is theta and here this is 90 degree and here there is another angle. Altogether it is 180 degree. This angle and theta and this angle makes 180 degree. Similarly, if this is the old triangle, then this angle is theta. This angle plus this angle and this perpendicular is 180 degree triangle. Both are 180 degree. Okay, this angle is gone. This angle 90 degree, common with this, gone. So this angle delta, this is delta h. This angle is theta because if the old triangle, this is radius, this is height h, and this angle is theta, then this angle is also theta. This angle plus perpendicular plus this angle is 180 degree. Similarly, in this triangle, this radius, this base and this height h is 180 degree. So this angle is common. This is 90 degree, that is equivalent to this 90 degree. Only thing remaining is this angle and here this angle. If this is theta, then this is also theta. If that is the case, then it is theta. If that is the case, it is theta, then cos theta is delta h, this is delta h by hypotenuse. If that is the case, then cos theta equal to delta h by r d theta. Cos theta equal to delta h by r d theta. D theta by r delta theta. Delta theta by delta h equal to 1 by r cos theta. Now can we replace there? There it is h delta h d theta by delta theta by delta h, or I'm sorry, actually it was integration, so it was sine theta d theta. So it is now h by r or 1 by r is outside, integration h dh into d theta by dh. Okay, now we have delta h. We are saying if it is very small, then it is delta d theta, delta theta. I'm sorry, I can rephrase it. So we have now delta theta by delta h equal to 1 by r cos theta. I'll replace delta theta by delta h to the d theta by dh. In that sense, it becomes 1 by r cos theta. R outside it becomes 1 by r square. 1 by r square h by cos theta dh is the integration. Cos theta is square root of 1 minus sine square theta. Then 1 minus sine square theta, sine theta is h by r. R will come, it will become a square root of r square minus h square. H by square root of r square minus h square. R will go as numerator. Here r square is there, 1 r will cut down and it become 1 by r integration h by square root of r square minus h square dh. Now this integration is minus square root of r square minus h square. Someone can calculate it. Minus square root of r square minus h square would this is the integration for the h by square root of r square minus h square. Someone can verify by differentiating it. Now, if this is the case, then we have found the result that integration of sine theta is nothing but 1 by r. Now, integration sign gone because integration is over. 1 by r minus 1 by r square root of h r square minus h square. I can push r inside, then minus a square root of 1 minus h square by r square. Now, h square by r square is sine theta, 1 minus sine square theta, cos theta, minus cos theta. Minus cos theta is the integration of sine theta. This one we derived. But what are the loopholes that we saw? What are the approximation or what are the things that we considered? It may not be true, but we consider. Can we go in depth of it? Okay, I may not come to the exact result, but I can dig into it. Now, what is the problem? First problem is that if this is the radius, if this is the base x-axis, this is the radius at angle theta. If that is the case, then I move delta theta in this direction. From here, I move delta theta. If I move delta theta, these 2 points I connected with this line. Okay, this line and this is the circle curve arc. This is the arc and this is line. What is length of this line? If arc length is r d theta, then what is length of this line? Actual length of this line. First thing, why our result is coming very perfect? That is the question mark, because this is, if this arc, if this arc is r, if this angle from here, if I take a line from here to the center, I take a line that is the radius, and from here I take a line to the center. If this angle is d theta, then this arc is r d theta, very perfect. But the line connecting two end cannot be r d theta. It is smaller than that, right? How it can be r d theta? Not possible. What is the length of the line that is connecting 2 points of the circle parameter? Now let's make angle d theta. If this is the, if there are two radius, if these are the 2 points of the radius and this is the line that is connecting, and angle between is delta theta, what is the length of this line? That is the question mark. If that is true, let's divide it like this. If that is the case, then this is a triangle, right angle triangle, and this angle is delta theta by 2. If this, what is this line? Okay, this is sine theta by 2, sine d theta by 2. Sine d theta by 2 is perpendicular by hypotenuse. That is, if this length is d, full length is d, then sine d theta by 2 equal to d by 2 by r. If that is the case, then d equal to 2r sine d theta by 2. So this length is 2r sine d theta by 2. The actual length is. But since d theta tends to 0, when d theta tends to 0, okay, in that sense, what is the length of the, right now, it is 2r sine d theta by 2. If d theta tends to 0, then sine d theta will be equal to d theta. This is what, if I take this approximation, then it becomes 2r into d theta by 2, then r d theta. If d theta tends to 0, and if I consider sine d theta is equal to d theta when d theta tends to 0, but not required. Now this length is actually 2r sine d theta by 2, not r d theta actually. Now we were talking about triangle that is formed. Now one side of the triangle is two end of the arc. This is the arc. Other side is parallel to the line x-axis, and other side is delta h. And we calculated that this angle is theta. Actually, it is not theta, because if I take the tangent at that point, if this is the circle and this is x-axis, and I rotate it theta degree from the x-axis, from here, if I draw the actual tangent, that tangent is perpendicular to the radius, not the line that connects from here to here. This line is not perpendicular to the radius. The tangent that is here, that is perpendicular to the radius. Okay, if that is the case, then this tangent, I'm talking about the tangent, a tangent and this delta H line, this is delta H line, and bottom is H line. This is H, and this is top is delta H. This tangent and this H is angle is theta. But we are talking about this point and another point little down. That is the point that is connecting the arc. If this, if this is the arc, if this is the arc, we're talking about this arc, then this connect two point in the arc. Okay, but if I go little up, then this is the actual tangent from this point. This angle is theta, not this angle is theta. So two error we are making. First we consider that the point, if this is, okay, this is x-axis and this is the radius, this is at angle theta, and this is one point on the circle. Now if I move delta theta, this is one point, this is another point. If I connect this is a line. But from here, if I draw tangent, this is another line. This is tangent line, this is this line. If that is the case, then from this point, old point, if this length, this height is delta h, this is a tangent line, this angle is theta angle. If we little go down, then this point and other point on the circle that is connecting. So two error we are making. One error we are making, that we are considering the point that is connecting one point to other point, this point angle with the vertical is theta. That is not true. The point that is tangent, if this is the circle, if this is the circle, at the point where angle is theta, at that point if I draw the tangent, this tangent with the vertical that is delta, this angle is theta degree. But if I draw a circle and one point and there is a delta theta point, one point, if I connect this line, then this angle with the vertical is theta plus some more degree. This angle is more. Okay, and this is one error. Other error is, if this is the curve of the circle, if this is angle theta and this is delta theta. If this is the curve of the circle, if this is the curve of the circle, if this is the curve of the circle, then these 2 points are connecting the curve. The curve is RD theta, but a straight line we consider angle as RD theta. So these two error compensate each other. That's why result is coming. Now this is the question mark, that how they compensate each other. If someone proves it that they really compensate each other, then he is proving something in his life. I tried little bit. So it is something like, if I take this line, straight line, there are two ways to solve this problem. There are two ways to solve this problem. What are the two ways? The first way is the line that is connecting these 2 points. This is the line that is connecting these 2 points. And this is vertical, that is delta h. This angle is, what is this angle? First I have to find what this angle is. If I know that angle, consider that angle is theta plus alpha. Vertical theta with theta angle with the tangent, and then from tangent this line is alpha, theta plus alpha. In that case, it is making one triangle here. This is what we talked. From this point, it is making a triangle here. From this point, this is the line that is connecting 2 points on the arc. 2 points on the arc. This is delta h. This angle is theta plus alpha, where this actual theta, that is tangent, is like this. It is hitting this parallel line somewhere in the middle. Okay, and this is delta h. This is delta h, and this is theta. If this is tangent line, if I bring this tangent line little down, then it becomes point connecting 2 points. If this is tangent and this is delta h, this is tangent, this angle is alpha, this angle is theta. Actual angle is theta plus alpha. So cos theta plus alpha is delta h divided by this distance, hypotenuse. So cos theta plus alpha equal to delta h divided by that side, that is 2r sine d theta by 2. Cos delta h plus, cos theta plus alpha, that is the new angle from the tangent to the actual line connecting 2 points on the perimeter, or So cos of theta plus alpha equal to delta H divided by 2r sine delta theta or d theta or dh by 2r sine d theta by 2. Sine d theta by 2, not sine d theta by 2. Sine and d theta angle I have to divide by 2. Sine d theta by 2. That is cos theta plus alpha. Now I can see what is alpha. Okay, let's draw what. Now I am simulating that scenario. Now consider this is x-axis. Consider consider this is x-axis. If this is x-axis, this is y-axis. I mean this is perpendicular. Now this is x-axis. If that is the case, then this is one line connecting this point. Consider this angle. This now consider there is a line like this. There is a line like this. This angle is theta. This angle is theta. Okay. Now I am moving this line little away. If that is the case, then extra angle it is making is alpha. This is what we are doing there, right? Now I can just rotate this side. I was doing like this. Let's rotate this side like this. It exactly becomes what we are trying. One line that is tangent and other line is is the is the point connecting two sides. This is point connecting two sides of the circle and this is actual tangent. Okay, we are talking about this angle. Now if I rotate this, we are talking about this angle. One angle that is forming with the tangent, that is theta. Other angle it is forming with the actual line connecting two points. This is alpha theta plus alpha. What is this alpha? Can someone calculate it? Now this is theta. This is alpha plus theta. But if this is alpha plus theta, this height is delta h. Someone can try. Someone can try. I tried it. I believe it is little kind of difficult, but someone can try it. Okay, if this is the radius, then this is the side that we are calculating. Okay, if that is the case, then this side is making alpha degree. This side is making alpha degree with the tangent. But if it makes alpha degree with the tangent, then this angles become 90 degree. Otherwise, it is not 90 degree. Okay. Now, what is this angle? This angle and this angle are same. This is delta theta. Okay. But if I move this alpha, then this become 90 degree. Can you see this? This is become tangent, right? If this become 90 degree, when I move alpha, and otherwise it was not 90 degree and angle was x and delta theta, then someone can calculate alpha. It becomes delta theta by 2. How come you can say like that? Makes sense, right? If this is a circle and this is the center, now this is at angle theta, then this is another line and this angle is delta theta. This is the point line that is connecting two points. This is the line that is connecting two points. If that is the case, then at this point, if I draw like this, this becomes tangent and it is perpendicular to the radius. It is perpendicular here. But if I connect this, it is not perpendicular here. But since since if I connect like this, but if this angle is delta theta, and if I connect like this angle and this angle are same. But consider that angle is x, then delta theta plus x, delta theta plus 2x equal to 180 degree. Now, if that is the case, then if I move little bit up and make a tangent, move alpha and make a tangent, in that case, that angle become alpha, and I mean full angle become 90 degree. In that sense, x plus alpha equal to 90 degree. D theta plus 2x equal to 180 degree. Alpha plus x equal to 180 degree, 90 degree. Multiply by 2. 2 alpha plus 2x equal to 180 degree. Now subtract, then it becomes d theta equal to 2 alpha. Alpha equal to d theta. Let's come back to the old equation. Cos theta plus alpha, cos theta plus alpha equal to delta h by 2r sine d theta delta theta by 2. Now alpha I can replace with delta theta by 2. Now cos theta plus delta theta, cos theta plus delta theta equal to delta h divided by 2r sine delta theta by 2. Now here with this equation someone has to find delta theta by delta h. If he finds delta theta by delta h, then it is solved. Okay, this is what we are trying, right? We are trying integration of sine theta d theta. Sine theta d theta is equivalent to sine theta dh d theta by dh. Same thing, dh will go away. Sine theta is h by r. 1 by r I can keep outside. If 1 by r I can keep outside, then integration of h dh d theta by dh, d theta by dh I have to find. Now here cos theta plus d theta by 2 equal to dh by 2r sine d theta by 2. Let's consider d theta tends to 0. If d theta tends to 0, then cos theta plus d theta by 2. D theta by 2 0 means cos theta. Cos theta equal to then delta h by 2r sine d theta by 2. Sine d theta by 2 will be d theta by 2 as per the 0. 2 2 gone. Cos theta equal to delta h by r d theta. Sine d theta by 2 becomes d theta by 2. 2 2 gone, r d theta. Cos theta equal to delta h by r d theta. This is what we have considered when delta theta tends. This is the actual proof. Okay, but in real case it is cos theta plus d theta by 2, cos in braces theta plus d theta by 2 equal to dh or delta h by 2r sine in braces d theta or delta theta by 2, braces close. This is the actual expression, and here someone has to find d theta by dh, delta theta by delta h, whatever comes that someone has to put. Someone can blindly think about, someone can expand cos theta plus delta theta by 2. And here sine theta by 2 is there. And then try it. What is expansion of cos theta plus delta theta by 2? Cos delta theta by 2 minus sine delta theta by 2 equal to delta h by 2r sine delta theta by 2. Then say sine theta someone can multiply, or someone can directly write like this. Then what is cos theta? What is cos theta? Okay, so cos theta someone can replace with the, or someone cos theta plus delta theta someone can replace directly. I don't know, someone can try. Okay, this is one thing. Other thing is that now remember that we tried this way. This is x-axis, this is x-axis, this is a perpendicular line. If that is the case, then this angle is theta. I mean this angle. This angle is theta. This is the tangent line. And this angle is theta plus alpha, that is theta plus delta theta. Let's proceed. We proceeded with this. Cos delta plus alpha theta equal to base by hypotenuse. Base is delta h and hypotenuse is 2r sine d theta by 2. So cos theta plus delta theta by 2 equal to delta h by 2r sine d theta by 2. Rather than proceeding with this, let's proceed with this, with the tangent. Then cos theta equal to delta h by the tangent. Now someone has to find what is the length of the tangent. I have not tried. Someone can try that. If I have a line that is with angle theta, it make a hypotenuse, then if I move delta theta, there is another hypotenuse, that is delta theta by 2. If this length is 2r sine d theta by 2 and angle is theta plus delta theta by 2, if I squeeze it little bit and it comes to theta, then what would be the length of this hypotenuse? If length of the hypotenuse I know, then cos theta is delta h by this hypotenuse. Simple, right? then it will be easier rather than going for cos theta plus delta theta by 2. Someone can try it. And then you find the exact integration of sine theta. This will be prize winning if someone really does it, then it is something like Nobel Award winning. It is very difficult. Someone can really try this way and he can crack the finding the integration of sine theta. Why this is important? Importance because integration is nothing but calculation of addition through calculating the area. For rectangle, we know that is x to the power 0. Height is x to the power constant into x to the power 0. The area is in term of x to the power 1. If it is a triangle, then height is x, then area is in term of x square by 2. If it is x to the power n, then it is x to the power n plus 1 by n plus 1. How we find? Through the product rule. Finding the x square integration is nothing but finding x into x. That we deduce the formula if you watch the previous video. Product rule in integration. Product rule in integration. Then it comes as x to the power 3 by 3. If that is the scenario, then we know that for polynomial, the integration or calculating the addition through the area is x to the power n is x to the power n plus 1 divided by n plus 1. Now, what about sinusoidal? For sinusoidal, if I find through integration only, then it is something that will give some big award to someone who tries this way. Then we know sin x. If I know sin integration of sin x is minus cos x, then what is integration of cos x? Integration of cos x is nothing but integration of 1 minus sin square x. Then someone can find it will come as sin x. If I know integration of sin x and cos x, what is integration of tan x? That is sin x by cos x. Through chain rule, through the integration by part, someone can find. Same way, full trigonometric equation someone can find. If that much is done, then someone can try log x ex. This is what I am saying. Anything begins from addition and slowly it came to area, integration, polynomial integration, trigonometric integration, log, exponential, and so and so. This is mathematics. Mathematics is a layered approach where a higher layer sits upon the lower layer. This is how integration primitive calculus very much we have made the video that talks about how calculus evolved. Anyway, we will see more on it and then other invention we have done. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.